Today I'm going to show you how we can just launch the SICU IoT platform application. As you know, SICU is designed to control and monitor patients' conditions in intensive care units of hospitals. So I'm going to show you how you can just launch different microservices into the IoT platform and also different settings and configurations that should be needed to configure it before the application launch. There are several microservices that are working together in SICU IoT platform, including device catalog and service catalog, which aims to register the devices and also the microservices into the system. In addition, there are other microservices, including some analysis tools like EKG analysis tool, oxygen saturation, and also blood pressure analysis tools. In order to store information and data into our system, we are using a MongoDB database microservice to store different reports, warnings, and measurements in our system. And finally, SICU benefits from two different user interfaces, including a web application, which is based on a Streamlit platform, that can be used in every single browser-based platform like mobile phones, desktops, or tablets. And also another user interface, which is a Telegram bot, which can be accessed into Telegram Messenger. All these microservices working together in order to gather, analyze, and also visualize the information created by our Raspberry Pi devices, which is a gateway between the sensors and also different microservices into our platform. In order to launch the application, I'm assuming that you have previously visited our GitHub repository, in which we have explained completely the different approaches to manage our environment and also install the packages that we need into SICU IoT platform in order to launch applications successfully. Now that we have the environment ready and all the packages installed into the environment, we can just start running different microservices. The source code is written in a way that you can just run different microservices in no specific order, since the microservices will wait for the service and device catalog to be run first, and then they will register themselves into the service and device catalog. But in overall, I suggest you first running the service and device catalogs, then running the MongoDB database, and then you can just freely using different microservices to be run in different orders. Here, as you can see, first I'm going to run the microservices instead of the service and device catalog in order to see what happens if you just do not run the service and device catalog first. As you can see, different microservices wait for the service and device catalog to be run, and then they register themselves, and then they can just start working. First, they're going to communicate with different communication points and endpoints, and then they will stop working. I should note that each microservice has a unique configuration and setting files that you can follow into subdirectories, and you can just modify them before you're running each microservice. It's important to just check the settings first and set the desired setting values and configurations, and then run the microservice itself. So by running the service and device catalog, now microservices can just see and communicate the service catalog, and they can just register their information and the endpoints into the service registry system. This information will be regularly updated into the service registry system. And also on the service catalog side, it itself starts to check the status of the microservices in a specific period of time, and if a service didn't send an update request, it will be removed from the current active services. And the same process goes to the device catalog, in which the devices are going to register themselves into the device registry system, and if the device couldn't send the update request into the device catalog, the device catalog thinks that the device is out of the order and it just considers it as an offline device. So now let's check the functionality of the microservices. We're going to execute the gateway device that we are going to use it as a bridge between the sensors and also the microservices into our platform. So I'm going to run and execute the gateway device file, which is actually hosted on the Raspberry Pi, and see what happens to different microservices. I should note that this gateway device includes 3 different sensors, including the electrocardiogram, the blood pressure cuff, and also the pulse oximeter, that it just gets the measurements from the patient in a real-time manner, and also it sends the measurements into different microservices that have been previously defined for the Raspberry Pi in order to send. Now that I'm running the gateway device file, as you can see, first it registers itself into the device catalog, and then different microservices are going to receive the information from the device, like the raw measurements. Some microservices like analysis tools are going to use these raw measurements in order to generate some warnings and reports. And also it's going to be stored into our MongoDB database, and the user interfaces, including the Streamlit and Telegram bot, are going to use these measurements in order to visualize them for the users. I should also mention that each different actions like sending or receiving messages or functions into microservices are going to be shown in the terminal for logging purposes, but the point is the body of the messages are set to be hidden in default. But if you want to see more details, you can just change these settings later into the settings files.
This is our Telegram bot that can show warning messages and report of analysis tools to user. By pushing a start, you can see signing and sign up box. First, you must register by enter organization name and then account password. This message sent to catalog, and the catalog gives you unique username and password depending on organization. Now you can sign in by entering this username and password. The system checks this username and password with catalog that they are exist on the catalog or not. In this time, you must add your device by entering the device ID and the password ID. You can find them in the purchase box. Now your device is added and you can see the report and warning notification of your device. For example, you can see blood pressure report and oxygen saturation warning.
By running the Streamlit web application, this page would be the first thing that you will face into the platform. As you can see, there are the same options as what we did in the Telegram bot, like sign in and sign up, and you can use your credentials to sign in, and also you can sign up again into the platform using an organization name and a password. Here we're going to consider the username and password that we have previously used in Telegram bot to create an account, and we're going to access the private area. After a successful sign-in, you can see your dashboard and private area. As like what we did in Telegram bot, you can see a add new device section on the sidebar, and you can just specify the device ID and its password in order to add a new device. Here also you can see in the main page of the dashboard that we have a device ID with the name of the ID that we have previously added into the Telegram bot. In the data tab, as you can see, we can specify the amount of monitoring time and also the update data frequency and get the live data from the database. By pushing the get live data, we are going to visualize the live data that is storing on the database. In the reports tab, you can see the full list of the reports of different kind of data categories, including the pressure, EKG, and oxygen. By specifying the report type, you can see the statistics that we have been previously defined into our platform and see also the time that the report has been created. In the warnings tab, you can specify the type of warning, including oxygen, pressure, and EKG, and you can see the full list of warnings that has been previously stored into our database associated with the device ID. The important point is, by choosing the warning type of EKG, you can also see the full envelope of the EKG during that warning time. So here it was a brief demo into a smart intensive care unit platform. Do not hesitate to contact us in case of any issues or questions. You can always refer to our GitHub repository in case of any problems and also instructions. You can reach out to us using the email address provided into the description.